Download this code from codegive.com, link in the description below. OK, let's dive deep into asynchronous module definition, AMD. This comprehensive tutorial will cover I. What is AMD and why use it? 2. Core concepts of AMD. 3. The define function. 4. Dependency declaration and loading. V CommonJS versus AMD. 6. Building with AMD. 7. Examples and practical scenarios. 8. Advantages and disadvantages of AMD. 9. Tools and frameworks. X best practices and optimization. 11. Real-world code examples. 12. Conclusion. I. What is AMD and why use it? Asynchronous module definition, AMD, is a JavaScript module format that allows you to load modules asynchronously in the browser. This means that you don't have to wait for all of your JavaScript files to load before the page becomes interactive. AMD is primarily designed for use in web browsers, where network latency and parallel loading are critical concerns. Why use AMD? Asynchronous loading. The primary benefit is asynchronous loading of dependencies. This improves initial page load time and prevents blocking the main thread. Dependency management. AMD provides a clear way to declare dependencies for your modules. This makes it easier to understand how your code is structured and to manage dependencies across a large code base. Avoids global namespace pollution. AMD modules are encapsulated, preventing variables and functions from leaking into the global scope, which can lead to naming collisions and unpredictable behavior. Reusability. AMD promotes modular code, making it easier to reuse modules in different parts of your application or even in other projects. Testability. Modular code is generally easier to test in isolation. 2. Core concepts of AMD. The core idea behind AMD is to define modules using a define function. These modules can declare dependencies, which the AMD loader, example require.js, will load asynchronously before executing the module's code. Key components. Module. A self-contained unit of code with clearly defined dependencies and a specific purpose. Dependency. Other modules that a module relies on to function correctly. Module loader. A JavaScript library, example require.js, curl.js, responsible for asynchronously loading modules and resolving dependencies. Define function. The function used to define a module, declare its dependencies, and specify its code. Require function. Used to load and execute modules outside of the defined scope, especially for the entry point of your application. 3. The define function. The define function is the cornerstone of AMD. Its purpose is to define a JavaScript module and make it available to other modules or to the application. It has the following signature: generalized. ID, optional, a string that specifies the module's name. If omitted, the module loader typically infers the name from the file path. Example script/mymodule.js might be named mymodule. Providing an explicit ID is usually best practice for clarity, especially when using bundling tools. Dependencies, optional, an array of strings, where each string represents a module that this module depends on. The loader will load these dependencies before executing the module's code. Factory, required, a function that returns the module's value, i.e., the object or function that other modules can import. This function will receive the loaded dependencies as arguments in the same order they are listed in the dependencies array. Examples: asterisk. Asterisk simple module, no dependencies. Asterisk module with dependencies asterisk. Asterisk module with a named ID asterisk. 4. Dependency declaration and loading. The dependencies array within the define function is crucial. It tells the module loader which other modules need to be loaded before this module can be executed. The loader will fetch and execute these dependencies in parallel, asynchronously, improving performance. How it works asterisk. 1. The module loader parses the define call and extracts the dependencies. 2. It checks if those dependencies have already been loaded. If not, it initiates asynchronous requests to load them. 3. Once all dependencies are loaded, the module loader executes the factory function, passing the dependencies as arguments. The order of the arguments matches the order in which the dependencies are listed in the array. 4. The value returned by the factory function becomes the module's export, what other modules can import. Example using require.js asterisk. Script/main.js, this is your entry point. Script/mymodule.js, the module definition. Make sure you have jQuery and underscore downloaded and placed in the scripts directory, or reference them from a CDN. Explanation asterisk. Asterisk require.js is the require.js library, which acts as the AMD loader. Asterisk data main equals script/main tells require.js to load script/main.js as the entry point. Asterisk in script/main.js, require, mymodule, loads mymodule.js and any dependencies it declares. Asterisk mymodule.js defines the mymodule module and its dependencies, jQuery and underscore. Require.js will ensure that jQuery and underscore are loaded before executing the mymodule factory function. CommonJS versus AMD. CommonJS and AMD are two different module formats that emerged in the JavaScript ecosystem. While they both aim to solve the problem of modularity, they differ in their approach. Feature CommonJS AMD. Intended use server-side, Node.js, browser-side. Loading synchronous asynchronous. Syntax require, module.exports define, require. Global scope modules are encapsulated. Module ID file path, typically, string or file path. Performance not optimized for network latency, optimized for network latency. Asterisk CommonJS asterisk uses synchronous loading, which is suitable for server-side environments where files are typically accessed from the local file system. Node.js uses CommonJS. Asterisk AMD asterisk uses asynchronous loading, which is essential for browser-side environments where files are fetched over the network. Example, CommonJS, Node.js. 6. Building with AMD. In production, it's generally recommended to bundle your AMD modules into a single file or a smaller number of files to reduce HTTP requests and improve performance. Tools like the Require.js Optimizer, R.js, and Webpack can be used for this purpose. Require.js Optimizer, R.js. The Require.js Optimizer analyzes your AMD modules and their dependencies and bundles them into a single file, optionally minifying the code. Example, using R.js. 1. Create a build configuration file, example build.js. 2. Run the optimizer from the command line asterisk. 3. Include the optimized file in your HTML asterisk. Webpack asterisk. Webpack is a more general-purpose module bundler that can handle AMD, CommonJS, and ES modules. It offers more advanced features, such as code splitting, loaders for different file types, CSS, images, etc., and hot module replacement. 7. Examples and practical scenarios. Let's look at some examples to solidify your understanding. Example 1, Simple Calculator Module. Script/calculator.js. Script/main.js. Example 2, Module that uses a template library. Script/template.util.js. Script/main.js. This example assumes you have handlebars configured correctly with require.js, example using a shim configuration. Example 3, a module for displaying data in a table. Script/datatableView.js. Script/main.js. This example renders a simple HTML table with data in the table container div. 8. Advantages and disadvantages of AMD. Advantages ***. Improved performance ** asynchronous loading reduces initial page load time and improves perceived responsiveness. Dependency management ** explicit dependency declarations make code easier to understand and maintain. Encapsulation ** prevents global namespace pollution and reduces the risk of naming conflicts. Reusability * promotes modular code that can be reused in different parts of the application or in other projects. Testability * modular code is easier to test in isolation. Disadvantages ***. Increased complexity * AMD introduces a learning curve and adds complexity to the build process. Overhead * AMD loaders can add a small overhead to the initial page load. Configuration * configuring module paths, shims, and build settings can be time-consuming. Less relevant with ES modules * the rise of native ES modules, ESM, in modern browsers and build tools has somewhat reduced the necessity of AMD in some scenarios. ESM offers asynchronous loading capabilities natively and avoids the need for a separate module loader. 9. Tools and frameworks. Require.js * the most popular AMD loader. It's lightweight and easy to use. Curl.js * another AMD loader with a focus on performance. Webpack * a powerful module bundler that supports AMD, CommonJS, and ES modules. It's more complex than require.js but offers more advanced features. Browse primarily a CommonJS bundler, but it can be used with tools to support AMD modules. Grunt/gulp * task runners that can automate the build process, including module bundling and optimization. Best practices and optimization. Use a build tool * bundle your AMD modules into a single file or a smaller number of files for production. Tools like r.js or Webpack are essential. Minimize HTTP requests * reduce the number of JavaScript files that need to be loaded by combining modules and optimizing assets. Use a CDN for libraries * load popular libraries, example jQuery, from a content delivery network, CDN, to leverage browser caching and reduce latency. Configure module paths * use the paths configuration option in require.js or Webpack to map module IDs to file paths. This makes your code more readable and maintainable. Use shims for non-AMD modules * use the shim configuration option to wrap non-AMD modules and make them compatible with AMD. Optimize images and assets * optimize images and other assets to reduce file sizes and improve loading times. Asterisk minify your code. Asterisk minify your JavaScript code to reduce file sizes. 11. Real-world code examples. Because most modern projects lean towards ES modules, finding purely AMD-based, large, open-source applications is challenging. However, many legacy projects still use AMD or transitioned from it. Consider examining the source code of older versions of JavaScript libraries or frameworks to see how AMD was implemented. Simulated real-world scenario, building a simple application using AMD. Let's imagine we're building a simple newsreader application. It has a module for fetching news articles, a module for displaying the articles in a list, and a module for formatting the article dates. Project structure asterisk. Script/API/newsservice.js asterisk. Script/UI/articlelist.js asterisk. Script/util/dateformatter.js asterisk. Script/main.js asterisk. Index.html asterisk. This example demonstrates how AMD modules can be used to structure a simple application with clear separation of concerns. 12. Conclusion. AMD is a valuable module format for building modular JavaScript applications, especially in the browser. While it's not as dominant as it once was due to the rise of ES modules, understanding AMD is still beneficial for working with legacy projects or for projects where you want fine-grained control over module loading. By using AMD effectively, you can improve the performance, maintainability, and testability of your JavaScript code. Remember to use build tools like r.js or Webpack to optimize your modules for production deployment.